All right, welcome back. And today we are going to talk about functions. Now, functions are used throughout programming. It's super important, so it's definitely vital that you understand what functions are and how to use them. Because no matter what language you're going to write in, or no matter what kind of programs you're going to create, you will have functions. Functions are basically the key to making your program run smoothly, and the reason because of that is because functions are reusable, flexible, and modular. We will talk more about that, but first, let's define what a function is. A function is a sequence of instructions that performs a specific task, packaged as a unit. Once again, I do want to stress that knowing this information about function will be useful anywhere in your programming career. So you should definitely understand what functions are. We've actually already seen a few functions. Now, remember when we used to do we used to print things? Look at the syntax of it. You write a certain statement like print, and then you have open parentheses, and then you write something inside it, and then you close parentheses. What does that actually mean? What this actually means is you're calling the name of the function. The name of the function is print, and then you put inputs into your function. And that input is a string, for example, or you could input a number and it would still work. So this function is pretty special because it prints stuff on the screen. Now, can you think of another function that we learned? Type. This is actually another function because the name of the function is type. And then what you put in is a number, a string, or a boolean, and then what it spits out, the output, will be the class of your object. And in this case, it's boolean. So those are functions. Now, guess what? We can actually define our own function. And the reason we want to define our own function is because we don't want to repeat the code we write. Because sometimes you've already written a bunch of code for a specific set of instructions, and you don't want to write that again and again throughout your program. You can just call the function. If that doesn't make any sense yet, don't worry about it. It will make sense in just 5 minutes. So here's an anatomy of a function. So what you can do is you can define a function of what they do. All right. So this is a special keyword, def. It actually means define. So here you're defining the function. And then this whole thing is actually a function definition. You are creating your own function now. So kind of in math, when you do f of x equals x squared. So f is the name of the function. And then here, x squared, that is the definition. I'll just write define because I don't have space. And then x is the input. And you could put anything you want inside of x. Well, maybe not anything, but any numbers because we're in the math world right now. So same here. Here, this whole thing is a function definition, or at least this part right here is the instructions. And then this is the function name. Just like in math, f is the name. Well, here it's hello. And then this guy is an input. You can actually have more than one input. We call these parameters, function parameters, but right now we'll just call it input. And the reason why they're called input is you input something in it, and then within the instructions, it's going to use your input to have the output. And the output is basically just the whole instruction set. And then what is this? This is another line. I'll show you more in real code later example, but once you've defined a function, if you don't call it, nothing happens. So kind of like if you define this function, but if you don't actually use f of x, then nothing is going to happen. And then here, you are calling the function. As you can see, you see this? This is the input. And in this case, you inputted Jonathan. So then Jonathan, the parameter name becomes Jonathan. Parameter is kind of like variables, but instead is within a function. So as you can see, you can use it the same way as a variable. Hi plus name, and then this name is the input that we've inputted. So this will actually become Jonathan because we write hello, Jonathan. What if we want a different name? We can actually call the function by saying hello, David. And then this will do the same thing, except that this time name will be David. So let's whip out some code and do the same thing. let's just copy the code from before. It was, what was it? Define hello, and then we have name as the parameter. And then what did we do? Let's go back and check. We had a variable called greet. Okay, greet. And then the variable greet was hi, exclamation part, space, I believe. That's right, hi, exclamation part, space, and then plus name. Name is the parameter. And then, okay, plus name. And then the last thing we did was we just print the greeting. And then at the end, we had hello, Jonathan. Now the thing about Python, you have to remember that these tabs or spaces are quite important because whatever is below and then you press a tab is more like whatever is the definition of hello is all of this. Everything that is after, right? But then if you go back, like for example, hello here, this is no longer within the definition of hello. That is called scope, okay? Now let's run, let's see what happens. We get hi, Jonathan. So what happened here? Well, what happens if I delete this line? Run. Nothing happens. That is because we did not call the function. Let's put it back and it says, oh, now it says hi, Jonathan. So what happens if I write hello, David? Now what I'm doing here is I am calling the function and I'm giving David as an input to this function. Now it becomes hi, David. See how great it is? So it's doing all these instructions that you would have done. For example, the long way would have done greet, hi, plus name. We actually did not define name right now, so it's not gonna work. So in some sense, it's the same thing as saying name equals David. Okay, we could use a different variable if we want, different name, like greeting equals hello, space plus name. Okay, and then print. So we're basically doing the same thing what the function did. And then it says hello David, but that took so long. Instead, I predefined it here, and as you know, as you remember, whenever I press run, what my program does is it reads all of these lines first and executes them, and then I can use the REPL right here, the interpreter. I can say hello and then David, and that would have been way faster than writing all these lines. Now, just to give you a little bit more understanding on the difference between the left side and the right side, the left side, you write a bunch of code. That's what we call code. And when you press run, it executes all of this. And then here, it actually executes your code too as you write them down. So what I'm going to do here is I'm going to copy this. I'm going to delete it. I'm going to delete this too. I'm going to run it. So if I write hello, is this going to work? No, it's not, because the function has not been defined yet, right? And then once I define it here, which is the same thing as if I would have written here, but right now I'm doing it real time. I press enter, and then now the function hello is defined. So now if I write hello, ASDF, it works, right? So this is what the difference is between the left part and the right part. The left part has been, the Python reads all the lines that are in here, and then on the right, I could do it in real time where I call certain functions or make certain changes. All right, so back to the beginning. There's one thing that might confuse certain people is print and also something new called return keyword. This return keywords means in your function, what does it do? What does it return? So remember how there's inputs, and then if you put input, there's gonna be output out of the function, and return tells you what the output is. So print is not an output. Print actually just prints something on the screen. That's why you could print it multiple times. You know, you could just print all of these functions, and then you're gonna see hello Jonathan ASDF. But what does the function actually output? In here, if you have a return statement, you're defining what you're outputting. So for example, let's have a variable. I'll just call it variable1 equals hello Jonathan. So then what happened is because it went through this function, it executed these instructions, you get a print greet, which is hello, hi Jonathan, and then you also printed ASDF. And then it returned name. So what happened? What was the output? Well, here the output was name. And what was name? Name was Jonathan. So what is variable1 going to be? Yes, that's right. It's gonna be Jonathan. It's the string Jonathan. Now, what if it's completely unrelated? Let's put 50. So now if we do the same thing, variable1 equals hello Jonathan. What do you think variable1 will be? Is it going to be Jonathan? No, it's because we returned 50. So this function returns the number 50. So variable becomes 50. So that is it. So these, what we call, are side effects. They're the side effects of the function. The function output is 50. These are just side effects. So now let's talk about why functions are so great. Now, as we saw here, we said that the functions are reusable. So what does that mean? Why is it so good? Well, let me give you a practical example. Here's a function I defined. It's called tip amount. So here's what it does. First, it prints, actually, you know what? We'll just try it. Let's just call it tip amount. And then here we have two parameters. So you actually put two things in there. So tip percentage, let's say it's 15, and then total, it means how much is your total cost. So basically what this function does is if you enter the tip percentage, like 15%, and total, which is the total amount of money that you spent buying something, it will output the total is 100, the tip percentage is 15%, so the tip amount would be $15. Now, it's reusable. Functions are reusable because imagine if I do some other stuff like, let's see, potato equals $100, and then, yeah, like that. So then I could reuse this function without having to write all these things, print. You know, that's a lot of stuff to do. And as a software engineer, you want to work smart, not hard. So you reuse this function so you don't need to type as much, right? So you could reuse it. So for example, this time it's 15% and also the cost of potato, right? Cool. Let's change the cost of potato to be 50, and I want to know what the tip amount would be. Well, it's really easy because you can call tip amount again because it's reusable. Functions are reusable. Okay, so the tip amount would be 7.5. What's the next thing? Why are they useful? Because they're flexible. And the reason they're flexible is because you can have parameters, right? So instead of writing this whole thing each time for a different tip percentage, we could actually just change it within this function. Like imagine if I hard-coded tip percentage to be 15%, then this function will only work if you had 15% tip. But now I could say, all right, well, I want to tip 70% or maybe 50%. Okay, how much? What's the tip amount going to be, right? So it's flexible. This function is very flexible. And then lastly, functions are also modular. What does modular mean? Well, in a high level, it kind of just means it's good for organization so that you can separate the concerns for different tasks. So a function can, like once you've written a function, you know that the function will handle certain tasks, so that your other program, if it depends on that function, doesn't need to worry about it, and they can just call it. So in some ways, it's kind of about organization. So for example, imagine if I have another function. Now I have a function called buy produce, and what it does is you tell them how many tomatoes you bought, how many bananas you bought, and how many potatoes you bought. These are the parameters, right? Num potatoes, num banana, num potatoes, num bananas. So 1, 2, 3, let's say I bought 1 tomato, 2 bananas, and 3 potatoes. And then, oh, whoops, that's not the function name. The function name is buy produce. And then what it does is it outputs, welcome to Joma Groceries. Today you bought 1 tomatoes, 2 bananas, 3 potatoes. Your total is $14. And then what happened is I called tip amount, but the tip amount also prints stuff. So what it did is right here, I was in the function buy produce. But then right here, I called the function here because I wanted the tip amount. And then it started to print these things for these command. And then at the end, I used the output of this function to say how many tips. So you know what? It seems like here it's kind of redundant. So how can we make this more modular? Well, to make this more modular, more organized, how about for tip amount, the only thing that this function should do is calculate the tip and return the tip amount. So as you can see here, it says none, tip mean none. It's because the return of this function is actually nothing. Remember when I said return should return the output of the function? Well, if the output of the function is nothing and I assign the variable tips to nothing, then when I said please tip me the string of tips, then it's going to be none because this actually doesn't output anything. We usually call this a void function, but let's not make it void. Let's return the tip amount, which should be total times tip percentage, right? So now this tip amount is going to return the tip total, the tip amount, I mean. And then what we want to do is delete all of these so that we don't print anything, because we want to make it modular. The only reason what this function does is return the tip amount. All right. So what happens if you write tip amount and you say 15% of, I don't know, $60? Okay, it seems like it works. This is the output. 15% of 60 is $9. Now, by produce, this function actually uses that function tip amount. So let's see what it looks like now. By produce, so like I said, I want to buy 1 tomato, 2 bananas, and 3 potatoes. All right, and then now it says, welcome to Joma Groceries. Today you bought 1 tomatoes, 2 bananas, 3 potatoes, and your total is $14. And please tip me $2.10. So now it works perfectly fine. So let's read the code to see if you guys understand what it means. In by produce, you first calculate the total price. This is a variable, and that variable is number of tomatoes times 2. So $2 per tomato, and then $1.5 for each banana, and $3 per potatoes. And then it has side effects. It prints this, welcome Joma Groceries. Today you bought, and then it's going to tell you how many tomatoes you bought. 1, 2, and 3 potatoes. And then it's going to tell you the total price, which is $14. And then it's going to tell you what you should tip. And then here, it's modular because it's organized. Because instead of rewriting total times tip percentage, you are going to write tip amount. You're going to use that function. And the great thing is, you can reuse this function just like this. What if I want tips more? And then instead, I want to calculate what the tip amount would be if it's 30%. That's kind of high. Let's say 20%. 20% of total price. And then I'm going to print, if you're feeling rich, give me $. And then I'm going to write tips more, which is the variable here, right? So what happens? Let's try to run this. All right, we run this, and then by produce, 1, 2, 3, 1 tomato, 2 bananas, 3 potatoes. So now you can see your total is $14. Please tip me $2.1. If you're feeling rich, give me $2.8. I know that this looks kind of weird, but this is not in the scope of the course. It's a floating point issue. But anyways, so as you can see, actually let's change the tip amount. Let's do like maybe 50. Okay, and then we'll buy produce. 1, 2, 3. Yeah, so here you go. You know, if you're feeling rich, give me $7. So as you can see, we've actually applied everything that's useful about a function within this code. Here, we could see that we're reusing the function, so we don't need to rewrite it. And it's flexible because we could give it the parameter 15% or 50% in terms of the tip amount. And it's modular because it's not within this function. This function, the whole point of this function is to display all of these Joma Grocery stuff, telling me how many things I bought, what's the total price, and what is the tip amount. And then for me to define how to calculate the tip amount, we just look at here. Right? And we just defined it here, so it's modular. Now imagine if I want to do something different. Imagine if I want to suddenly change the way we calculate tips, is that we just add $5 to it. So now we don't need to modify the code here, so that's why it makes it modular. So I only need to modify the function that requires modifying. So if we run this again and we write by produce, 1, 2, 3, suddenly the tip is increased by $5 because we've changed the function here. So now instead of just 15%, it's 15% of total plus an extra $5. So that's pretty much functions, and I hope you understood what happened. And this is super important because for any language, for any program, you will be using functions a lot, right? So it should be your bread and butter. Functions are bomb. All right. We define a function and we usually specify the instructions right here. we specify the inputs, and we specify the name. And then we call the function by calling the name, and then we open parentheses and close parentheses. Functions are flexible, functions are reusable, and functions are modular. It helps you organize programs into distinct units, and it makes them so that editing your code is much easier, so that your entire program is organized and modular. All right, thanks for watching, and I'll see you in the next one.